We're going to do amines and amides in this video. They're very similar molecules. They both have nitrogen, but one of the main differences is that the amine, if you look on table R, it's a little complicated. Table R shows you what can be like what's called a primary, secondary, and tertiary amine. Basically means it can be in the center of multiple chains. You're never going to have to name that. You're only going to have to name a amine that functions very similar to like an alcohol. The same way an alcohol, for example, is an OH that just gets stuck onto a carbon. A amine in our world is going to be an NH2 that gets stuck onto a carbon in place of an H. We're never going to have to worry about naming the more complicated ones. I don't know why they even include it on table R, but let's name them. So we're going to do this one, 3-hexenamine. So hex means 6 in a row. So you put 6 in a row. Then you number them, because obviously I need a numbering system because they have something numbered here. And then they say carbon 3 is where I have my amine. That's what it means. So I go 1, 2, 3. And there's my NH2. You could draw out the bonds for the H's if you wanted. You don't have to, so I wouldn't bother. And that's it. And that's all you do. Then you add your H's in. And then we condense. So carbon 1 is a CH3, carbon 2 is a CH2, carbon 3 is going to be a CH with a NH2 next to it. Now I didn't put it in parentheses, and the only reason I didn't put it in parentheses is because on table R, when they condensed their NH2, they didn't use parentheses. Carbon 4, carbon 5, and then carbon 6. And that's everything for amines. It's just an NH2 that gets stuck onto a carbon chain the same way an alcohol would substitute an H, the NH2 substitutes an H. Amides are a different thing. They are actually kind of similar to a organic acid, right? Where the organic acid is the double bonded O with the OH here. It has to be at the end of a chain because of that. This is a double bonded O with an NH2 there. So it's like a combination of a amine and an organic acid. It's the NH2s taking the place of the OH. So, but because of that, they have to be at the end of the chain. So it shouldn't be too terrible to write this thing out. So let's do this long one. Carbon 1. So 6 carbons in a 6 CH2s in a row. So that gives me 1, 2, 3, 4, 5, 6, 7 carbons in a row before I get to the functional group. 1, 2, 3, 4, 5, 6, 7 in a row. And then this carbon right here is just going to be a C with a double bonded O, and then an NH2. Again, you can uncondense or condense the H's, it doesn't matter. Now, if we look at table R, and let's see how they named their amine or amide. So again, it's really an NH2. Don't worry about this because you can have primary and secondary amides, but we're never going to get that. It's too complicated. So they just called it propan amide because it's 1, 2, 3 in a row. Amine's always on the end, so it doesn't get a number. So let's count this one out. 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 in a row. So it would be octane, O-C-T-A-N-E, and now it's octane or octan amide. Done. That's all you had to do. You literally just changed the first part of the name to reflect that there's 8 carbons in the chain, as opposed to on table R, they only gave you 3 carbons in the chain. And that's it for amides.